Hi Year 10. For the week beginning the 11th of May, I thought I'd give you an opportunity to see your teacher because I know you're probably missing school like crazy and pining and scratching at the bottom of the door. Right, focus for the 11th of May onwards is a complete consolidation. Different people are at different places. Now, only a couple of you have managed to get all the work done that I wanted from you so far. If you're one of those people, as an extension, I'd like you to do some more secondary data and research and look at this visit around rivers. If you've done lots of that, you might want to start looking at Milton Keynes, just finding out a bit of information about the actual city, a bit of the history and writing it down. For the rest of you though, my intention now is to go through lesson by lesson what you should have done and give you a bit of support and guidance. Right, on the 23rd of March, when we started this crazy lockdown, we started to look at, we were recapping on evolving physical landscape and namely looking at rivers. So first of all, I asked you to look at the document online 10.1 river profiles, which looked at drainage basins, long profile, valley profile. And also, if you owned the revision guide, which I hope most of you have, then page 54 would help you to get that information together as well. Then there's a worksheet, which is online 10.1 Rivers A, which asks you to fill it in, and it's questions about drainage basins, long profile, etc., etc. So that's lesson 1. Lesson 2 was moving to the revision workbook, okay? And on page 54, you were to answer the questions on river systems. Within that, there's a guided question, which is number 4 on channel characteristics. And then you were to do page 56, which is upper course features. I think I listed it as lower course features as a mistake, but it's upper course features, and there's no guided answers in that one or questions at all. Then turn to page 127 and 128 at the back of the book to mark, purple pen, and highlight, write in and highlight any key words and key expressions that will help you to revise from that when you look back over that in the past. Lesson 3, you should load up online 10.2, which is about Bradshaw, a PowerPoint. Now, as we're going through this, folks, pause me, go away, look at the work and come back. This one video should suffice for the 3 lessons this week. So hear what I'm saying, go away and do the work, and then come back to me again. Okay? You also, in the revision guide, if you've got it, should be looking at perhaps page 56 to 58. And also, that's on upper and lower course features. And then you work through the PowerPoint and you complete any task on it as instructed, please. That gets us on to the second week of the lockdown tasks that were being set. On the 30th of March, I set 3 lessons. Lesson 1, you should have looked at PowerPoint 10.4, online 10.4, River Flooding 1. You scroll through that and you complete any tasks that appear on it. Now, what you should also do, you should watch the 2 videos on it, and you should be able to fill in a quick chart or copy the diagram on it, which shows the human and physical causes of flooding. Now think about that. Human causes of flooding, generally urbanisation or covering the land so there's no infiltration of water into the soil, which will of course cause much faster surface runoff. Water will get in the drains, so into the rivers, much quicker and cause flash flooding. It could be that we're using the land for something else. It could be farming, it could be anything. But humans can really affect the infiltration. Deforestation is a huge issue here because if you cut trees down, you stop interception, so you increase the speed of surface runoff. On the physical side, of course, when we looked at places like Sheffield, they had prolonged heavy rainfall. It was a steep-sided valley. Combine those two and you've got serious runoff. It could even be a simple case of being something like granite, which is impermeable. Water can't infiltrate, it has to run off the surface and down towards the river. Okay? On that 10.4 flooding one as well. There's a 10-minute, or it's slightly less than that, video of Attenborough's climate change. Watch that, it does focus on urbanisation. If you've got the revision guide, also turn to pages 61 to 63. Have a read through that because it focuses on river flooding. Once again, pause me as you get to the point where you need to pause me. Okay? Right, we move on. Lesson 2. We went to the revision workbook again. We should focus on page 62, increasing flood risk, easy for me to say. There's a helped question there, which is number 2. So you just carry on writing what it said. A guided question. On page 63, you're also doing managing flood risk with a guided question started on number 3. You then go to page 128, you mark your work, purple pen, adding anything in, and then with a highlighter, once again, highlight keywords and expressions, which will help you when you actually revise from this document. Lesson 3, you moved on to online 10.5, River Flooding 2. This looked at antecedent occurrences. Now, antecedent is things that happened before the flood to make the flood happen. So it could have been events from days ago, weeks ago. In Sheffield in particular, they'd had prolonged heavy rainfall. It had been raining for about a week. So that was antecedent. It was well before the floods, but it led to the flooding. So you also get an opportunity within that PowerPoint to look at how to put together an answer on flooding. There are flow diagrams that I've given examples of. An example of that would be deforestation. Deforestation equals or leads to lower interception, which leads to greater surface water, and then of course faster surface runoff, faster water to the rivers, flash floods, etc., etc. So any question you get, you can learn that answer in a simple loop of a flow diagram to put the answer together before you answer it. Something I would scribble in the corner of a piece of paper on an exam so that I could then write that out so I know what it means. Okay? I want you to complete any tasks on that PowerPoint, but it's mainly to familiarise yourself with this whole idea of drawing hydrographs. Do you remember we looked at the highest rainfall and we looked at the highest point of the river, and the difference between those two was the lag time, how quickly that water got into the river. So highest rainfall to highest flood height of river is lag time. And if that lag time's short, you're talking flash floods, serious problems. The second part of the lesson was to go to the revision workbook, do page 60, storm hydrographs. There's a guided question in number 2. Then you go to page 61 and you answer the questions on river flooding. That's an 8 marker, so an important one. You might want to have a go at doing a flow chart when you put that together. You turn to page 128 to look at how to mark it. You mark it, you purple pen it, and you highlight any work that you've got that is new to you, or any keywords, etc., etc. On the 20th of April, returning from Easter, we did a project week. Now, you were presented on that sheet with numerous websites. It's on the actual one that says week beginning the 20th of the 4th. They focus on flood risks on the River Wye in Buckinghamshire. Now, what some people have done is they've gone away and looked at the River Wye and they focused on the River Wye in Wales. I promise the one that runs parallel with the Bristol Channel and the River Severn isn't the one that comes through Buckinghamshire. The one in Buckinghamshire is only about 10 miles long. So please, when you do your focus and your research, it's the River Wye in Buckinghamshire. Okay. Remember, you've looked at human and physical causes of flooding, so have that in your front of your mind as you're doing this. And what you've got to do is you've got to put together a little presentation, and it's looking at flood risks on the River Wye. Now, this little presentation, probably easiest to do it in the form of a little PowerPoint. So you're going to say, location of the Wye. Where is it? Look it up. If you can get a little diagram, a map of it, insert it, copy and paste, get it in, all right, so you can show what it is. Where's the source? Where's the mouth? The source is actually in the Chiltern Hills. The mouth is the confluence with the River Thames. But find out where, put it in. Terrain and relief. Now, terrain means the shape of the land. Is it steep? Is it bumpy? What sort of rocks is it? Relief is the height of it. You know, is it mountainous? Is it flat as a pancake? Tributaries, which rivers flow into it? Urbanisation, how much building is there along the course of this river, which creates this surface runoff because there's nowhere for infiltration to happen? Does it correspond to Bradshaw's model? We looked at Bradshaw, didn't we? And we looked at the fact that he said that velocity of a river increases the further downstream you go. Particle size gets smaller. Channel width, channel depth get greater. So anything you can find out about the River Wye, see if it corresponds with Bradshaw. There are other areas to look at which are on the bottom of that page as well. On the 23rd, well, I'm not going to show you that one because we've just gone past that. On the 27th of April, we started to look at fieldwork visits. So this is linked directly to the photocopied handouts that you took home. So the information can be found on here. And this is about fieldwork considerations, things we should look at before we go into the field. Now, what you were asked to do here is to draw like a simple little mind map with the River Wye in the centre and going off in different tangents to location, access, suitability, time and river conditions. Now, to help you out on that a little bit, even though you've got it in those photocopied packs, location. Where are we going and why are we going there? What's the distance? What's the price of that travel? We've got to think about that. How much time are we spending travelling there? Is it a sensible amount of time and do we have enough time at the site? Is there phone coverage? Think about an accident. All right, what threats are there? I said before, you wouldn't stick a Montague where the Capulets were. So you wouldn't want to be somewhere where you can be bothered by individuals or animals or anything else. Suitability. Is it the proper and the best place to go to collect the information that you require? Is it safe? Is it convenient? Access. Think about legalities. Is this public right of way? You don't want to trespass on someone's land to go and look at your river. But think safety as well. Access. Getting into the river. Getting out of the river. Is it safe? Can you get an ambulance there if there was an incident? Think safety. Time. Is there enough time to get there? Is there enough time to actually complete what you've got to do? Is it close to school, therefore? You know, think about travel. You don't want to be doing your research in the dark. River conditions. Think flooding. No. We just don't go near the place. If it's been pouring with rain, you stay away because the water level is going to rise. Lesson 2 was about writing a risk assessment. Now, this is a legal requirement. You must eliminate every potential risk before you go on a trip like this, however small the risk. So we look at hazards, which are the possible dangers. We look at the risk rating. That's just how dangerous you think it is. Is it, you know, if you look at something like someone slipping in the river, then what's the risk rating of that? If the water's quite fast, pretty high, I should imagine. But then we have to look at a control measure. So what are we going to do to prevent that from happening? So what we might do is just find a really safe area where the water isn't gushing through. It's very easy access. No one's likely to slip over. The ground is quite flat. And it's not slippery. So we've broken down this hazard, this risk has gone. So the outcome, which is the final column, should say, right, that's been reduced to low now because we've taken every consideration to make sure it's safe. Now, when you're doing this, some people have done risk assessments already and have done them quite short. I want you to refer back to all that stuff about location, suitability, access, time, river conditions, because they should be in your risk assessment. The risk assessment should be quite a big document. Go for it, all right? Right, lesson 3 of that week. So what are we going to look at? We have to, this is what the board says, we have to investigate river processes and management using fieldwork and research. Now, the research obviously is going to be our secondary data, which is the stuff we collect from the internet, stuff that we don't research, but we get it from there, okay? Your field work is obviously your primary. That's the questions you answer by being on site. So we've looked at flooding. We've looked at human and physical causes. So we could use that as an inquiry question. But we've also looked a lot at Bradshaw, his model, channel width, channel depth, velocity, particle size, etc., etc. So an inquiry is really a process of investigation to find the answer to a question. It's brilliant practice. It's something you'd have to do for A-level and certainly have to do in your thesis to get a degree at university. So we need a question as a starting point. Examples then. Think about Bradshaw. We could ask the question whether a channel width and depth and velocity always increase downstream. So we would need to take measurements on all of those at perhaps the source, the middle course and the lower course to ensure that it is increasing. If it doesn't increase, for whatever reason, we need to work out why, because it could be something that's affecting Bradshaw's model, which isn't the most natural thing. When we think about flooding, we might look at whether different methods of river management can offer longer term solutions. So we could look at soft engineering, which might be just digging another channel, putting some sand down, doing something quite simple, widening a river by digging a piece of the mud away. Or we're going to look at hard engineering. Have they put wood or concrete or metal structures to stop this water from flooding over the edges? So which one's most effective? We can look at that and look at flooding. You've got to come up with a question in this lesson, all right? So you're going to visit 2 sites and I want you to think about what type of measurements could you need for this? What are you going to have to look at? So get some ideas in your head. And obviously, think about what secondary data you might want to collect in doing this. Last week, or the Monday just gone, 4th of May, may the 4th be with you, as they say, it's the bank holiday week, so we only set 2 lessons. Lesson 1, we basically looked at our handout, our photocopied handouts on page 214, and we were looking at titles of sample size, survey location and sites, and accuracy. And it was a case of getting these written down with definitions and what they mean. Now, if you think about sample sizes, there's more in your handout, but surely 1 sample, is that really accurate? Or do we want to take more samples? Does it generally go, the more samples, the merrier, because you're going to get more information. You could even take a mean and work it out. Survey location and site. Think risk assessment. Think transportation. Think about how you collect it. For instance, if you're going to do river depth, are you going to do a straight line across the river channel? That's called a transect. And are you going to split the channel into, say, 10 and do a measurement at each 10th of the river and then take a mean average? Very sensible way of doing it. Accuracy. How can we ensure this? Start thinking. How can we make sure we've done everything to ensure that our records are absolutely correct? Lesson 2, right? Pages 214 and 215 from the photocopied handout. We're going to look at different types of qualitative and quantitative data. Think about that. Qualitative, quality. What's the place like? Is it nice? Is it horrible? Etc., etc. Look at quantitative, quantity, anything we can count. So we can measure channel width and channel depth. We could look at flood defences and say, are they aesthetically pleasing in a quality sense? Are they ugly? Are they going to put people off? Okay. So we need a definition for qualitative and a definition for quantitative. We then need to copy and paste the data table, the qualitative data table that I put on that sheet, and fill in the missing gaps. Most of it should come from the sheets 214 and 215 of the handouts. However, some of the qualitative stuff might take a bit of creativity on your part and a bit of a thought from you. So really think about that. You might want to ask your parents or anyone at home. What I'm really keen on you doing then is consolidating everything we've done this week, or up to this week. So from next Monday, the 11th of May, make sure you've completed all of this. I'm going to give you those 3 lessons for everyone to catch up completely and get the work handed in. Now, to hand it in, you go to OneDrive, Year 10, Hand In, Geography, Mr. Cronin or Miss Bradford. Stay safe, everyone. I'm still available on mcronin@prioriacademy.co.uk. Contact me like many people have, Sophia, Adam, Rebecca. I've had lots of people contacting me to ask questions, Taylor, etc. Not a problem, please do. I'd rather you ask me if you don't understand so that we can sort it out and you can just do it once and do it correctly rather than repeating and repeating. Take care of yourselves. I'll set the work obviously for the week following that on the 16th, 18th. I'm really good with maths. Take care. Bye-bye.